we have studied addition of vectors. Means addition, we have studied triangle law of vector addition, polygon law of vector addition, and parallelogram law of vector addition. We are going to study subtraction of vector. Graphically, I will explain how the vector is being subtracted from other vector. So, let this is the vector A, and there is another vector B. Now we have to subtract the vector B from the vector A. Addition of the vector we have studied. So for subtraction, what do? We just find the negative of this vector B and then we add. Means suppose we have to find A minus B. This we have to find. And this is equivalent to, this is equal to A plus minus B. As far as vector is concerned, so A vector plus minus B vector, that will be equal to A minus B vector, where B is to be subtracted from A. So this can be done by taking the negative of this vector. See, if B is this, then minus B will be just parallel vector. Length will be same, because length tells the magnitude of the vector. So magnitude is not changing, only direction is changing, because minus tells the reverse direction of the vector. So this will be minus B vector. Now A and minus B will be added. So addition process we know. We will proceed like this is a vector A, and we have to add this vector minus B. For that we have to put the tail of this vector minus B at the head of the vector A, as we have already studied. If you recollect, if you have seen my previous video, then you will understand how the addition is being done. So parallel vector I will draw, and this will be parallel to this, and this is minus B vector. Now A and minus B is added, so this vector directed from tail of A to head of B, and this, suppose this is the vector R, then this represents A vector plus minus B vector, that is equal to A minus B vector. Therefore R vector is equal to A minus B. So how the subtraction is being done? Graphical method. You can see first negative of the vector we are taking, and then we are adding it. I will take another example. That is the first example. Second example we will take. Suppose this is a vector P. This is a vector Q. Two vectors are there. This is vector P and this is the vector Q. And we have to find 2P minus 3Q. Suppose this kind of question is there. Vector P is given, vector Q is given. We have to find 2P minus 3Q. It means we have to find 2P first. So for representing the vector 2P, direction of this will remain same, but length will be twice. Then it will become 2P. So if we draw a vector like this, then this vector represents 2P vector, because direction is not changing. I have changed the length. It is double than that of this, because we want 2P. Then we want 3q. Q is this. So we will draw another vector parallel to this and direction will remain same. This will become 3q. Length of this 3 times that of this. Now these two vectors are known, 2p and 3q. Now we have to subtract. So for that we want minus 3q, means direction will be reversed. So this is 2p, 3p direction will be reversed and that will be parallel to this. So I will draw a vector like this. This vector. This will represent minus 3q. This will become minus 3q. Are you getting? First q was there, I made 3q. Reverse the direction, minus 3q. P was this, double the length, it is 2p. Now this vector joining tail of this 2p to head of the vector minus 3q, this represents R1 vector. Suppose that will be 2p vector plus minus 3q. I am intentionally writing this way to make you understand this. We are following the triangle law of vector addition. These two vectors are being added. So this can further be written as R1 vector is equal to 2p minus 3q. So this is the direction and this length is the magnitude of subtraction of 3q from 2p. So I think subtraction of vector is clear to all of you. Now we will take another bit. This is also very important. You should understand it, listen it carefully and observe it. Every vector can be represented in terms of given two vectors. So any vector we are considering and two vectors are given, so that particular vector can be represented in terms of the given two vector. What is the physical significance of this? You see, suppose this is the vector A and another vector B. Two vectors are given. And a third vector, suppose this vector P is there. This P is to be represented in terms of these two vectors. What is this? Every vector can be represented in terms of given two vectors. So these A and B two vectors are given and this vector is to be represented in terms of A and B. How will we do this? See, I will draw the vector P first. This is the vector P. These two vectors are given. So we will draw from the tail or from head, either of these two we can select. This vector A, parallel to this vector, we will draw a line. This is the line I have drawn. It is parallel to the vector A. And the vector B is given. So I will draw a line parallel to vector B from here. Suppose I have drawn this line. This is parallel to B. And this part I will rub it off. Now if I put an arrow head over here and put arrow head over here, then what happens? This is A, this is B and this is C. In this triangle, these vertices I have given name to it. This is A, this is B and this is C. Now you see, AC vector is parallel to A vector and arrowhead put in the direction of arrow of the vector A. It means direction of this AC vector and A is same, but length is more. means magnitude of the vector AC is more than that of A, where direction is same. When two vectors are there and both are parallel, direction is same, only magnitude is varying, then we say it is scalar multiple of the given vector. So this AC is the scalar multiple of A, means it can be written as lambda vector A, because only magnitude is varying, direction is same. So this AC vector has to be a scalar multiple of the vector A. In the same way, now this is B. So direction I have changed, just parallel to this, the opposite, that will be negative, right? That is some scalar multiple of B. Here direction is this. I have taken the direction this. It is immaterial. Direction has been changed. So what will happen? Here the scalar multiple will be a negative quantity, isn't it? Because direction has been changed. So this can be written as mu B. Here mu will be negative. Why? Direction is this, that of B, and I have taken the reverse direction. The reverse means only sign changes. Once this is positive, then this direction will be negative. But that will be scalar multiple, because magnitude is more. That too I will explain separately, then things will be clear. So since I had made direction this, that is why I am continuing with that direction, isn't it? So only direction is changing, opposite direction. If it is positive, then this will be negative, but that negative quantity is still, it is a scalar quantity. It means this will also be a scalar multiple of B. Right? Is it clear? Now, if triangle law of vector addition, if we see, then AC is a vector, it is this, mu B is another vector, tail is here, right? So an AB vector, so that vector AB is sum or addition of the vector AC and CB. We can write AB vector is equal to AC vector plus CB vector. Is it clear? It is triangle law of vector addition. AB vector is P. It is vector P is equal to AC vector, means AC is lambda A plus CB is mu B. It means this vector P is represented in terms of A and B. Given vectors A and B, and P is represented in terms of the given vectors. That was the our main heading. So we can understand any vector P can be represented in terms of the given two vectors, right? Here this lambda A and lambda B, these are called the components of the vector P, where lambda A and mu B, lambda A and mu B are the components of vector P. So things are clear. Any vector can be represented in some of these two vectors, and lambda A and mu B are called the components of the vector P. Even though I have explained how CB is mu B, even the direction of B is this, mu will be negative in this case. That I will explain. this is B, right? Suppose I have to write minus 2B. So first, this will be 2B, direction is same. And what will be minus 2B? Simply, this is the vector in opposite direction, this will be minus 2B. Here, scalar multiple is 2, which is positive. Negative, here it is minus 2, because direction has been reversed. So this scalar multiple is minus 2. In the same way, B is this, direction is this. CB in the reverse direction. So it is a scalar multiple. But this scalar multiple will be a negative quantity, as in this case. I think there won't be any doubt anymore. Now we will talk about rectangular coordinate system and the unit vectors along the axis of the coordinate system. We will draw coordinate axis. This is x axis and this is y axis. Any point in this plane is represented by with two reference axes. Whereas if the point is in space, suppose over here, it is not in the plane. It is called three-dimensional coordinate system being used over here to address this point. So that I will tell you later. For this, in a plane, if some point is there, suppose there is one point P whose coordinate is x, y. It means from origin, one has to move x along x-axis, then y along y-axis, then we will reach at this point P, and P is the address of the point in this plane. Let the position vector of this point P. What is position vector? That we have already studied. The position vector of the point P is, suppose it is A. We will drop a perpendicular from here. This is 90 degree. Suppose it is Q. If we take OQ as a vector and QP also as a vector, then this position vector A represents some of these two vectors OQ and QP by triangle law of vector addition. Here, this length OQ represents the magnitude of the vector OQ. Now you see the vector OP. OP is equal to OQ vector plus QP vector by triangle law of vector addition. OP vector is equal to OQ vector plus QP vector. Now, this vector OQ vector means we know, we have already studied any vector represented by magnitude and direction. Magnitude means length of the vector and direction means unit vector along the direction of the vector. That we have already studied. Now, unit vector along this tells the direction above x-axis. The unit vector along this axis is represented by small I. Unit vector along x-axis. Similarly, along y-axis, J is the unit vector. Unit vector along y-axis is equal to J. So unit vector along x-axis is I, unit vector along y-axis is J. Now, OP vector represented by A, so we will write A vector over here is equal to OQ vector means this length. So we will write OQ. I will not write make arrow over it because it is a magnitude I am showing. This length I am telling you. OQ into unit vector along OQ, and that is I. You can write this plus QP vector means QP, this length, and unit vector along this is J. So we will write J, and let this length is represented by AX suppose, and this length is represented by AY suppose. Of course, AX is equal to X over here, right? This is equal to Y over here. So this can be written as, therefore, vector A is equal to AXI plus AYJ. This is rectangular resolution of the vector A. Means in two perpendicular directions, these are the components as we have studied in the previous article, that AXI is one component, AYJ is another component, and these components are perpendicular to each other. That is why it is called rectangular component of the vector A. This can be written as vector A is equal to, because AX is equal to X, so we can write XI plus YJ. This can be written like this also. So this is the rectangular components of this position vector of this point P, or we can say A is resolved in two directions, along x-axis and along y-axis, where AXI is the component along this, AYJ is component along y-axis. It is the resolution in a plane along two rectangular directions. I mean along two rectangular axis in the plane, but in 3 dimensions. If the point is in the space here, and suppose that is the corner of the room. So corner to this point, this is the position vector, and 3 axis is this wall and the floor. If they are meeting, intersecting, they are creating one axis. This wall and this wall is joining, they are intersecting, they are creating another axis, and floor and this wall, it is creating the third axis. So when the point is in space, then the reference axes are three rectangular coordinate axes, and these rectangular coordinate axes are mutually perpendicular to each other. So it can be represented like this. These are 3 axes, that is x-axis, this is y-axis, and this is z-axis. Let there be any point over here, S. So its coordinate will be x, y, z. X, y, z will be the coordinate of this point. Of course it is z. Then we will draw perpendicular on this plane, then perpendicular on as x-axis. So here it is origin, it is A, B, and it is vector Q suppose, or vector R we can take. This is the position vector of the point S. Let OA is equal to QX along y-axis, that is QY, along z-axis, that is QZ. These are the 3 distances. This is QX, it is QY, and QZ. because once you draw perpendicular from here and then on the x-axis, so this is along y-axis, this is along x-axis, and this is along z-axis. This, and this. Unit vector along x-axis, along y-axis, unit vector is j, along z-axis, unit vector is k. So this vector q can be represented in terms of I, j and k. This qx is the magnitude OA, qy is the magnitude AB, and qz is the magnitude of BS, this length. So we can write the vector q is equal to qxi plus qyj plus this qzk. These are the representation of any position vector considering the unit vectors along axis. It is for 2 dimension and that is for 3 dimension. This is clear to all of you. If 2 axes are there, then x and y we are taking, and 3 axes are there, the point is in the space, then I, j, k are the unit vectors along x-axis, y-axis and z-axis, and any vector, any position vector is represented in this form, or x, y, z, because qx is equal to x over here, qy is equal to y over here, and qz is equal to z, because x, y, z is the coordinate of the point S. So this can be written as q is equal to xi plus yj plus zk also. If you notice, I am putting cap on the unit vectors everywhere, because the previous lecture I had told you every unit vector is represented by putting cap over it. It distinguishes with the vectors and the unit vectors. I think up to now whatever is taught is clear to all of you. So wish you all the best. Take care.